Alright, so we're about to start a unit on factoring. So the very first thing we're going to do is we're going to prime factor today. So we're going to look at what the difference is between a prime and a composite number and how to factor those numbers. So one of the huge things in this unit for you to know are your divisibility rules. You know most of these rules. If you don't know one of them, I want you to highlight them as I go through them with you to make sure that those are the ones you study. So there's rules for numbers 1 through 10. As you start to factor numbers, or today when you're finding the prime factors, you're going to go through your 10 divisibility rules. And once you go through your 10 divisibility rules, you should be able to factor out the numbers completely. So obviously every number is divisible by 1, right? So 1 is a factor of every single number you can think of. Then the next rule is 2. If the number is even, in other words, if it ends in 0, 2, 4, 6, or 8, 2 divides into that number. A lot of you like to default to dividing a number by 2 and then 2 again and then 2 again. This is the last number I would divide anything by unless it's my only choice. Only because it takes you a lot longer to divide if you just keep dividing by 2. The next divisibility rule is 3, and you'll notice that 3 and 9 have exactly the same rule. You add up the digits, and if that sum is divisible by 3 or 9, then the number itself is divisible by 3 or 9. So I put an example here. Both of them are the same example. So 153, if you add up 1 plus 5 plus 3, those are the separate digits, you get 9. Isn't 9 divisible by 3? Isn't it also divisible by 9? So both 3 and 9 go into this number. So if I had, let's think of a number that's divisible by 3 but not 9. Can you think of one? Well, think of one that's 2 or 3 digits. 111. So 111. If you add 1 plus 1 plus 1, don't you get 3? So that number is divisible by 3 but not 9. Any number divisible by 9, isn't it always going to be divisible by 3 as well? Because 3 is a factor of 9. Thank you. All right, and then the next rule is 4, and this is the one that you avoid all the time because this is one that you don't know. Will you hand this over to Sean? This is one that you're not all that familiar with. You should be able to tell if any 2-digit number is divisible by 4, just based upon your factors. All right, but once you get to numbers bigger than 2 digits, like 3, 4, 5 digits, all you have to do is look at the last 2 digits of a number. So I use the number 1,324. If you look at the last 2 digits, in this case 24, is 24 divisible by 4?
Yeah.
Then so is 1,324. And then you know, okay, I'm going to go divide that number by 4. And we're going to use this rule here in a minute with 8, but we'll come back to that. 5 you already know. If a number ends in 0 or 5, 5 divides in there. Number 6, if the number passes the 2 and the 3 rule, in other words, if it's even, and you add up the digits and 3 divides in there, then 6 goes in there as well. So as you're going through your divisibility rules, if you know that 2 and 3 divided in there, then you know 6 does too. 7, there's actually a rule for 7, but it's so complicated, you might as well just divide the number by 7. There are a lot of numbers divisible by 7 that you don't realize that you think is prime. You need to actually divide it out. Like for instance, 91. 91 is divisible by 7. How many times does 7 go into 91? 13 times. So 91 is a number that you guys tend to tell me is prime because it ends in 1, but it's divisible by 7. So 7 is kind of a surprise number. Always check it. 8, here's how the 8 rule works. So if the number is divisible by 4, so if it passes this rule, so we're going to take 1324. And the quotient is even, so I have to actually apply the 4 divisibility rule and do it. So I'm going to take, I'll do it in pink. I'm going to take 1324 and I'm going to actually divide it by 4. How many times does 4 go into 13? 3 times. So 4 times 3 is 12. Subtract, I get 1 left over. Bring down the 2. How many times does 4 go into 2? 3 times. So 4 times 3 is 12. I get 0. Bring down the 4. How many times does 4 go into 4? Once. So the answer to this quotient was 331. What this rule is saying is if this quotient, in other words, after you divide by 4, if this quotient is even, then 8 goes into the number as well. Is this even? No. So 8 does not go into 1,324 because what's 4 times 2? 8. If we divide the number by 4 and we can't still divide it by 2, 8 can't possibly go in there. Then 9 we already talked about. 10, if the number ends in 10 or in 0, it's divisible by 10. So these are your important rules. I'm guessing that 4 and 8 and 6 you're unfamiliar with. And then 7 you need to get in the habit of testing. So, you know, these ones in the middle here, aside from 5, you need to become familiar with. Have this with you today as you do your homework. All right, so let's flip it to the back. Eratosthenes was a Greek mathematician who discovered this thing called a sieve. It's like a colander. You know how you put something through a strainer? Doesn't some things stay in the strainer and some things filter out through the strainer? This is going to filter out all of your what are called composite numbers, and you're going to be left with your prime numbers in the strainer, so to speak. And all you have to do is follow these 6 steps right here. So we're going to start with step number 1. And if I were you, I would use different colors for each step if you can, because then this will make more sense. So step 1, we're going to cross out number 1. Number 1 is not considered prime. I could argue with you that it is, but we're going to, you're going to see what the definition of a prime number is in a minute, and we'll talk about why 1 isn't prime. So we're going to cross that one out. Then you're going to circle 2. 2 is your smallest prime number, and it is the only prime number that is even. Every other prime number is odd. This is the only one that's even. And the directions say cross out other multiples of 2 because they're not prime. Remember, a prime number, what do you think the definition of a prime number is? What do you remember? Okay. A prime number means that its only factors, in other words, the only thing that divides into it is 1 and itself. So aren't all of these numbers here divisible by 2? So they have factors like 12 has more factors than just 1 and 12. Factors are things that multiply to give you 12. So factors of 12 would be 1 and 12, 2 and what? 6 and 3 and 4. So it has more than just one set of factors, 1 in itself. It is not prime. And neither is anything divisible by 2 because that means more. 2 goes into that. It gives you another set of factors. Then count every 2. Cross out the whole 4's column because all of those are divisible by 2. Any other even number, all of these are divisible by 2. And the 8's column, all of those are divisible by 2, and so are anything that 10 divides into are also divisible by 2. Oop, you can't see the whole thing. All right, then step number 3, oh, we just did that. Step number 4, circle 3 because it's prime. The only numbers that divide into 3 are 1 and 3. Now, be careful. You have to count every third number and cross it out. So make sure it's divisible by 3. Some of them are already crossed out. So 1, 2, 3, 6 is already crossed out. 1, 2, 3, 9, you need to cross it out and keep going. So every other one you're going to end up crossing out. Make sure that the number you cross out is actually divisible by 3. One is a number that a lot of you think is prime also, but 5 plus 1 is 6. 6 is divisible by 3. A lot of you don't realize 57 is divisible by 3. So then step 6 says circle 5 and 7, but we're going to do them separately. Circle 5 first, because 5 is the next number that's not crossed out. It's prime. The only thing that divides into it is 1 and 5. That means that anything divisible by 5 should be crossed out. Well, I have this chart arranged in rows of 10. So aren't all of these ending in 5? Whatever's not crossed out, cross it out. So 25, 35, 55, 65, 85, and 95. And then the other column that's divisible by 5 are the tens column. Didn't we already cross it out when we crossed out the 2's? So we don't have to worry about that one. The last one that we have to do is the 7's. So 7 is the next number that's not crossed out. It is also prime because only 1 and 7 divide into it. Now you have to count by 7. If it's not crossed out, cross it out. There's going to be a lot of them that are already crossed out. 14 is the first one. The first one that you come to is what that hasn't been crossed out? 49. That's the first one that hasn't been crossed out. And then 77. And then there's that 91. That's can't even talk. That's divisible by 7. That's it. So then the last step says we stop after 6 and 7 because 7 is the greatest prime whose square, 49, is less than 100. What's half of 100? 50. So that's their point, is we've already gone through half of it. If you try to go to the next one that's not crossed out, 11, you're going to find that everything divisible by 11 is crossed out. So just 11's easy to check, aren't they? All the numbers that are doubled, 11, 22, 33, 44, 55, and so forth, aren't they all crossed out? Right? So there's no need to go any further. So what you are going to do, if I were you, I would take a highlighter and highlight the ones that are not crossed out. So you've got 2, 3, 5, 7 in the first row, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Did I miss any? Now, it is your responsibility to know all of your prime numbers by heart from 1 to 100. They're really, first of all, you know most of them already. So there aren't going to be a whole lot for you to memorize or to learn. So here's what I would suggest you do. So today is Friday. The next time we'll meet is Tuesday. So I would suggest that you cut this off here and here. You should already know your primes of 2, 3, 5, 7, 11, 13, 17, and 19. Most of you can get that far. Then that means you only have to learn 4 of them, 23, 29, 31, and 37. So if I were you, I would learn this on day 1, which is today. For our purposes, today is Friday. Then you're going to learn these by day 2, which would be tomorrow, or in our case, Tuesday. We're going tomorrow's school days tomorrow. So Tuesday. And then this is day 3, which would be day after tomorrow, which in our case is Wednesday, right? If you look at these last 2, aren't there only about 10 in each one, that less than 10 that you have to memorize? And the reason why it's important for you to memorize them is you've already learned perfect squares, right? Perfect squares from 0 to 225. There's only 15 of those. You need to recognize a number. Is it a perfect square or is it prime? Because those are special numbers and they're going to help shorten up your work just like the factor patterns I taught you in Unit 8 are going to shorten up your work for this unit. If you know your divisibility rules, your prime numbers, your perfect squares, and those factor patterns, this is going to be a piece of cake for you, so to speak. But if you don't do this right here, then you're going to be in trouble. I will do a pop quiz after day 3. So sometime after Wednesday, you're going to have a pop quiz where you will have only 1 minute to write down all the primes from 1 to 100. And I time it on purpose so that you can't go through this and figure them out by using this seed. So you have to know them by heart. And they need to be in order, because otherwise I'm not grading it if it's not in order. It's a nightmare for me to grade. So learn them, okay? Isn't that fun? That's my gift to you. All right, so put that away. Then take out your notes. Whoops. We're going to do some real short notes today. We're going to start out simple. Oops. All right, so 9-1, and you're going to notice if you've looked at the calendar on my website, I don't know how many of you do, we're going to spend 2 days on nearly every type of concept. So we're spending a whole month on this unit. If we're spending a whole month on this unit, it probably means it's difficult, right? So, and it's important. It's difficult and it's important because you're going to see this over and over again in every math class you have. So we all have to learn it. All right, so this is day 1. And we're going to look purely at factors and greatest common factors. Which, for our purposes, you'll see me calling it GCF all the time. So we don't have to keep writing out greatest common factors. So let's define what we were just doing, finding prime numbers. So let's define what is the true definition of a prime number. Here's the true definition, and you tell me why 1 is not a prime number. The definition is, for a number to be prime, that it must be greater than 1 with 1 and the number as its only factors. Now remember, factors are numbers that multiply to give you another number. So why is 1 not prime? Because the definition says greater than 1. That right there, because I could argue that 1 is prime until you tell me, oh, it has to be greater than 1. Oh, well, okay. Because technically you could argue that 0 is prime too, right? So that's why the definition says greater than 1. So then a composite number means what? If a number is not prime, what is it? It's composite. It falls into one of those 2 categories. So it is a number, and by the way, the definition here also says greater than 1. So 1 is considered neither prime nor composite. So I guess I'll take that back a little bit. So this definition says greater than 1 with more factors than 1 in itself. So most numbers fall into either the prime or the composite category. So what if I put 1 on your test and said, is it prime or composite? What would your answer be? Neither. What about 0? Neither. All right, so let's look at some examples. Example 1. This is all you're going to do today. So I'm going to give you an example of everything that you might come across on your homework. And this should all be review. You are going to factor each number completely. Bless you. Use your divisibility rules. classify as prime or composite. So I have 3 examples here, and I factor in a very specific method for a very specific reason, and I'll show you why. So here's the first number that we're going to factor, and then I'll have you do some on your own. So we're not going to do that one. I'm going to do that one on your own. So we'll go down to C. I want to do C with you, and B is going to be up here. So we're going to do C together, and then I'm going to give you A and B, and then you're going to do those on your own. You're going to classify them. So here's the number I want you to factor, 84. Here's what I want you to do. I've seen a lot of different ways to factor, and a lot of you just kind of throw out numbers, and you go, okay, 1 and 84, and oh, I don't know, 4 and 20, what? 1. Could I miss some doing that? Just kind of a hit and miss kind of thing? There's a lot of factors to 84, by the way. So it's possible you might miss some if you just kind of go, I think this goes in there. Well, I want you to go through your divisibility rules, number 1. And number 2, I want you to use a horseshoe method. In other words, you're going to go down in one column and it'll go back up the other column. And the reason for that is you're going to know when you're finished with all of your factors. There won't be any guess. You'll know when you're done. Whereas some people will do it all in a straight horizontal line. Number 1, you can miss factors that way, and number 2, you don't really know when you've hit the middle of your factors. So always start with 1 in your number. So I know that 1 times 84 are my first 2 factors. Then what's your next divisibility rule? What's your very first one? For 2. Does 2 go into 84? Yes. How many times? 2 goes into 8 4 times, and 2 goes into 4 twice. So now we're only looking at the factors between 2 and 42, by the way. We've cut down our factors, because before we had to look at all numbers from 1 to 84 to see which ones went into 84. Now we're only looking at 2 to 42. The next number is 3. Does 3 go in there? How do you know? What's 8 plus 4? 12. 12 is divisible by 3, but not by 9, because I'm going to apply the same rules together. So when we get to 9, it doesn't go in there. So I know 3 goes in there. How many times? 3 goes into 8. How many times? Twice. What's left over? 2. So that's 24. 3 goes into 24. How many times? 8 times. So now I'm only checking the numbers from 3 to 28. So I've cut down my search. Does 4 go in there? Now it's a 2-digit number, so you just have to test it. Does 4 go in there? 4 goes into 8 twice, and 4 goes into 1 once. Now my search is cut down to between 4 and 21. Does 5 go in there? Nope, it doesn't end in 0 or 5. Does 6? Do you see how 2 and 3 went in there? So does 6. So if 2 and 3 went in there, because we already tested that, I know that 6 goes in there. So 6 goes into 8 how many times? 8 once. How many is left over? 6 goes into 8 once. How many is left over? 2. Put a 2 in front of the 4. 6 goes into 24 how many times? 4 times. So 6 times 14. Now I'm only looking at the numbers from 6 to 14. I have quite a few less now. 7, you better test it. A lot of you will just go, nope, 7 doesn't go in there. Test it. Does 7 go in there?
Yeah.
Yes, it does. 7 goes into 8 how many times? Once, with how many left over? 8 minus 7 is 1. So put a 1 in front of the 4. 7 goes into 14 how many times? Twice. So now I'm only testing numbers between 7 and 12. Does 8 go in there? Look at the quotient. Is that even? 8 doesn't go in. So 8 doesn't. How about 9? What do we remember about 9? No. Does 10 go in there? It doesn't end in 0. Does 10 go in there? No. 11. Is it double digits? No. And then we're back to 12. Because I've now rounded this bend, so to speak, we are finished. There's no more numbers to test. Because if I test 12, won't it go in there 7 times? There's no more numbers between 12 and 14. So in other words, 13 doesn't go in there. If I test 14 to go in there 6 times, there's no numbers between 14 and 21. So my point to you is if you use the horseshoe method, once you round the bend here and you start going back up this column, you know you're done. Is this prime or composite? Composite. All right, so I'm going to put 2 numbers up here. They won't be quite so involved. So I'll put 2 numbers up here, and I want you to factor them and then tell me if they're prime or composite. The first one is 22, and the second one is 31. So go through all your divisibility rules and factor them. Bless you. So let's talk about these real quick. Look up here, because you should be done by now. One of the nice things about knowing your prime numbers is not a prime number. Do you have to even use your divisibility rules? If you didn't know that this was prime, your first factors would be 1 and 31. You'd have to start using your divisibility rules, 2 through 10. And then once you exhaust 10, you'd have to start testing 11 all the way through 31. Well, once you get past 10, you need to start testing only prime numbers past 10. Because you've already tested all those other numbers. 2 through 10 will go into those numbers that you've already tested other than a prime number. So that will shorten it up, but if you don't know your prime numbers, you're going to be in trouble. If I know that that's prime right away, I'm done. I don't have any more work to do. 22, 1 and 22, and then 2 goes in there, but once you test 3 through 10, they don't go in there. 3 doesn't go in there because 2 plus 2 is 4. 4 doesn't go in there because 4 doesn't divide into 22. 5 doesn't go in there, it doesn't end in 0, 5. 6 doesn't go in there because 3 didn't. 7 doesn't go in there because it doesn't divide into 22. 8 doesn't go in there because 4 didn't go in there. 9 doesn't go in there because 3 didn't go in there. And 10 doesn't go in there because it doesn't end in 0. So you should be able to apply those rules really, really quickly, but you got to know them. All right, so you're going to do some of that. Then one other type of problem. So prime factorization. Some of you do it correctly, some of you don't. So let's talk about it. If you're asked to prime factor a number, that means that you are going to break that number down. So you're going to break a whole number. We will factor some negatives, and I'll show you how to factor a negative, but a whole number is 0, 1, 2, 3, 4. You're not going to prime factor decimals or fractions. TJ, what are you doing? Put it away. So you're going to prime factor a whole number down to the product of its primes. Some of you have been taught to start with the smallest prime number 2 and keep dividing the number by 2 until it doesn't go in there anymore, then go to the next prime number, which is 3, and divide that in there until it doesn't go anymore, and then the next prime number, which is 5, and so forth. That is long, exhausting, tedious, and boring. I would hate that. And so example 2, we're going to do a couple of them. Here's what I would suggest you do. Prime factor the number. So let's take that 84 that we looked at before, and I want you to prime factor 84. So prime factoring is different than find the factors of, and you have to know the difference between those directions. On an exam, if you ask me, what does prime factor mean, I'm going to tell you you're supposed to know what that means. Or you know, what's the difference between factoring and prime factoring? I won't tell you on a test because that's part of what I'm testing. So I suggest you use factor trees. How many of you have used factor trees before? Okay. Some of you have used repetitive division. I would not suggest repetitive division. I hate it, hate it, hate it. I wouldn't do it. So using your divisibility rules, choose the biggest number, typically from 2 to 10, that divides into 84. Now, we already went through all of the divisibility rules before, but off the top of your head, most of you probably would choose, hopefully not 2, but you might choose 4, right? I always like to apply the 3s and 9s rule because typically that'll get me one of my larger numbers, 9. 8 plus 4 is 12, so I know 9 doesn't go in there. So probably you're going to start with 4, would be my guess. It doesn't matter what you start with. You could start with 2, but I don't like starting with 2 unless it's my last resort. So 4 goes into 84 how many times? 21 times. Are either one of these prime?
Yeah.
No. Nope. So it's important again to know your prime numbers. You're going to keep prime factoring with factor trees until you're down to the primes. Now it's a tree. The prime is what we're looking for, so that's the fruit on the tree. So when you get to a prime number, you're going to circle it so it looks like an apple or an orange or whatever. If you don't circle your primes, they're going to get lost in your factored trees. So 4 can still be factored into what and what? 2 and 2. Those are prime, right? So circle your prime numbers. You cannot have a tree branch coming out of a piece of fruit. I've never seen it. It would be a freak of nature if that happened, right? I've never seen it. In all of my 45 years, I've not seen it. So that means you're done. So then go to your 21. It factors as what and what? 7 and 3. And then circle those because you're supposed to know that those are prime. So now we're done, except you can't leave your answer this way. You must write it out from smallest prime to largest prime. And there are 2 different ways you can write it out. An expanded form, which is stretching all the primes out, or an exponential form, which means it's base with its exponent. I would assume that you're always going to put it into exponential form unless otherwise told. So if nothing is said, you better not leave it that way. What's your smallest prime out of all of these? 2. So how many 2's do you have? 2. So it's 2 squared times with a dot, not an x. The next smallest prime is 3, and the next is 7. This is the proper answer form for prime factoring a number. So then the other one I'm going to give you is negative. I'm going to get you started and then you can do it on your own, but I want to show you what to do when the number is actually negative, because it does say a whole number. So what if I had negative 132? You're going to factor your negative out first. So your very first branch on your trees are going to be negative 1 and 132. And you're going to circle negative 1 even though technically it's not prime, because we need to take the negative 1 out of it. Now you factor 132. Use your divisibility rules. Don't start with 2. Start with your biggest number first. What's your biggest divisibility rule that goes in there? Apply your 3's rule. What's 1 plus 3 plus 2?
9.
What's 1 plus 3 plus 2? 6. So yeah, so 3 goes in there but 9 doesn't. Okay. Does 4 go in there? Because it goes into 32, so that's higher than 3, so I'd probably start with 4. You could try 7. I usually don't use 7 at this point unless I absolutely had to, because I don't like to have to divide it out. And so I would start with 4, personally. Thank you. And then 4 can be divided out as 2 and 2, which are both prime. And 33 is 3 and 11, which are also both prime. So then when you write out your prime factoring in exponential form, the negative 1 must come first because it is considered the smallest. And then 2 squared times 3 times 11. I know this sounds picky, but if you don't have them from smallest to largest, I am going to count you off, because there's a reason why we do this, and you'll see later. All right, so that's all you're going to do today for your homework. Any questions? Yes? Absolutely. Yep, absolutely. And if I were taking a test or a quiz, I would always do that, just because it's easy to make a mistake on these. In your first quiz, you don't want to make a mistake. You don't have any quizzes next week other than perhaps a pop quiz on prime numbers. So enjoy your long holiday.